Hi pre-algebra students, welcome back for day 2. The first thing we're going to do today is review your homework on squares and square roots. You'll remember we did these two handouts yesterday. Now you need to keep them in a safe place because you're going to need them throughout the school year. So you may want to hole punch them and put them either in a folder or a notebook or a binder so that you'll have these to refer back to. These notes will be helpful to you as we do some different things throughout the year in math. So the first thing I want to do is go over your homework. So everybody should have that out. I need the teacher to go around and just check and make sure that everybody has theirs done. If they don't, then you'll need to write down their name and they'll need to call their parents and let them know that they will be staying after school for detention to get their squares and square roots homework complete today. All right, so you can pause the video if you need to go check on the homework, and then once you're done, just go ahead and come on back. All right, so let's go ahead and go over the homework, and you can check yours as we're going through this. And if you have any questions, just go ahead and write them down afterward when I explain them. So in case you don't get it, we'll be able to review that, and I can help you when I get back. All right, so the first question says, which of the following is a true statement? So which thing is accurate? To square a number, I multiply the number times 2. So that's saying that if I'm squaring a number, it's the same as saying 9 times 2. Well, that, as an example, that's not true. When I square a number, I'm not multiplying anything by 2. The inverse or opposite, inverse is a fancy math word for opposite. So the opposite of squaring a number is to divide the number by 2. So that's saying if I had, for example, the square root of 25, that I would divide 25 by 2 to get my answer, and that's not true. When we think about the square root of 25, we know it's 5. I'm not multiplying 5 times 2 to get 25. To square a number, you multiply the number by itself. Well, that sounds true. So that's the same as saying to square a number, if it's 9 squared, that's the same as saying multiply 9 times itself. Well, that is true, but we're going to keep going because that's what good mathematicians do, just to make sure that that's the best answer. A perfect square is a number whose square root is an even number. Well, that's not always true. Looking back at our example here of 25, if I find the square root of 25, the answer to that is 5. 5 is an odd number, not even. None of them have to do with whether a number is even or odd. It's just whatever the base number is that you're multiplying by itself. So the correct answer for number 1 is C. That's just the basic definition of what a square is, a square number. Number 2, which of the following is not an example of a perfect square? So yesterday, when we were doing our squares charts, which number did you not see on there? So perfect square, well, I know 9 is the same as 3 squared. 200, I don't think that is, but let's keep checking. So 4 is 2 squared, and 64 is the same as saying 8 squared. If I thought about that, the square root of each of those numbers is a perfect square. 200, not so much. So 200 is not an example of a perfect square. Number 3, which of the following has a value that is less than 0? So thinking back to yesterday, we know that if I have a negative in parentheses, that's saying the same as a negative times a negative, and that's going to give me a positive answer. So negative 6 squared, this would have equaled 36. So you really need to go through and solve these. If I'm going to square this, well, 1 squared is 1, and 3 squared is 9, 1/9. That's still a positive number. 5/10 squared is the same as saying 5/10 times 5/10, which is 25 hundredths. Still a positive number, not less than 0. In this case, this is where the parenthesis comes in and is important, because in this case, I do not have a parenthesis with this negative 7. So that means I'm going to square the 7 times 7, and then I'm going to put that negative in front of it. So 7 times 7 is 49, and then because I don't have the parenthesis, my answer is a negative 49. So in this case, our answer was D. Here, they basically want you to explain what we just talked about over here. Well, what's the difference between these two? So the difference between -5 in parentheses squared and -5 squared, when I look at these and I solve them, -5 in parentheses squared, a negative times a negative is a positive, is going to equal 25. Whereas I'm just going to take my base number 5 and I'm going to square it, and that's going to give me 25. But because I don't have my negative in the parentheses, this is now a -25. So that's the difference. You got to be really careful with those parentheses because it changes the value of your number. All right, so let's go down and solve these expressions. So this one is 9 squared plus 3 squared. So I'm going to go down and solve all these. So 9 squared is the same as 81 plus 3 squared, which is 9. So 81 plus 9 is 90. So 90 should have been your answer for number 5. Number 6, 14 squared is the same as 196. And then 196 minus the square root of 144, which is 12. So 196 minus 12 is 184. 184. All right. 5/6 squared. So I'm going to just square each number. So 5 squared is the same as saying 5 times 5. And then 6 squared is the same as saying 6 times 6. So this is the same as saying 25/36. So the answer is 25/36, which is a mouthful. All right, this one, number 8. So remember we said that anytime we have a number before the square root symbol, but we don't have any kind of symbol, that's the same as telling us, it's signaling to us that we're going to multiply. So I always put that dot there. It tells me we're going to be multiplying. 100 square root of 144, it's a perfect square. 100 square root of 144 is 12. So if I multiply 3 times 12, that's just a basic math fact, I get 36. All right, so this is a two-step problem here. So 5 squared is 25, a whole number. And then what I'm going to get here is a fractional value, the square root of 49/64. So these are both for perfect squares. The numerator and the denominator are perfect squares, so I just square them. The square root of 49 is 7, and the square root of 64 is 8. So all I'm doing is adding a whole number, 25, to a fractional value of 7/8. So this is the same as saying 25 and 7/8. 25 and 7/8. All right, number 10. All I'm going to do here is find the square roots of both of these numbers, and then I'm going to add them together. So the square root of 225 is 15, plus the square root of 169, that's 13. So this is just the same as saying 15 plus 13, which is 28. 28 is the answer here. All right, so now we're taking that math knowledge and we're going to be putting it to use in some real world scenarios. So this says, Michelle purchased a kid's table with a square top. Here's the table with the top. If the area of the square is 400 square inches, what is the length of one of the sides? So if I'm thinking about this, area again is within that area. Think about this as the fence, and think about the grass like on the soccer field as the area, and the perimeter is the fence. So I'm going to be finding the square root of 400. And when I find the square root of 400, all right, so when we're talking about the square root of 400, if I think back to my square roots chart, I know that the highest I got, that 15 squared, was 225. So manually, I would recommend writing 16 times 16, 17 times 17, 18 times 18, 19 times 19. The square root of 400 is 20. So that means that each one of these sides is 20 inches, the perimeter. So the perimeter of this would be 20, 40, 60, 80 inches. But in this case, it's saying what is the length of one of the sides. So the perimeter would be 80 inches, but the length of just one of those sides is going to be 20 inches. 20 inches. Now again, when we start getting into bigger numbers like this, you're probably going to have to keep writing out more of the perfect squares. Right now, that's what we're working a lot with, are the perfect squares. So I would just write out more of your multiplication tables for now. All right, and our last problem on the homework says a pyramid has a square base. So we're talking about a square pyramid here, a three-dimensional shape with an area of 196 square feet. Anytime you see that little 2 and it's on an exponent after any kind of measurement, it means square of whatever the unit is. What is the perimeter of the base of the pyramid? So when I'm talking about this, the pyramid would meet up at a point up here in the air, but the base of it, when I set it down, is a square. So the area of that is 169 feet square. And in order to figure out the perimeter, I have to take the square root of 169 feet, and that's going to tell me what's the length of each side. So I know that the square root of 169 is 13. So that means each one of these sides of the square pyramid is 13 feet. And what it's asking me to figure out is the perimeter. So I'm going to add 13 plus 13 plus 13 plus 13. That's all I'm going to do here. So 3, 6, 9, 12. Regroup my 1, 2, 3, 4, 5. So the perimeter of the base of the pyramid is 52, and I have to put down the measurement. So 52 feet. So that's kind of a multi-step problem. The first one tends to be a little bit more simplistic, and then the second one is kind of taking it to that next level. So that's our homework from last night. If you have any questions, just kind of hold on to them, and I will go over them with you when I get back to school. So now we are going to move into our lesson for today. So let's change over to the next video. The next video is going to be on fractions and decimals. So go ahead and stop this video and move on to the next video with fractions and decimals. It'll be handout number 2.